Oh. Hello everyone, January 5th. I had a bad session today, training session. It was so bad. So bad. I don't feel any power. I barely cleaned 205 pounds. I couldn't even jerk it. And the squat, I was like just struggling, and then my right groin was also hurting, so it's kind of overused since I came back from the holiday. I was pretty powerful earlier this week, but yesterday I kind of maxed out on the powers, on the power snatch and power clean. I'm pretty happy with what I get there. But dude, this is bad. This is so bad today. And also I did a little bit too much on snatch, I have to admit, because I feel like the form is degrading. And yeah, overall it was a session to forget. I don't like it. I don't like it at all. All right, so let's stop talking about yesterday and today's session. Let's get down to the business. Maximum profit. I might have done this before. Yes, I have done this before. Maximum profit and job scheduling. We have end jobs, where every job is scheduled to be done from start time to end time, obtaining a profit. You're given the start, end, and profit arrays. Return the maximum profit you can take, such that there are no two jobs in the subset with overlapping time range. If you choose a job that ends at time X, you will be able to start another job that starts at X. So in the first one, so mostly these type of problems, you sort the range by either the start or by the end. Naturally I like to sort by the start, right? So if you sort by the start, this is actually already sort for you. You sort it by the start, right? And then okay. What we want to know is, if we have no overlap, what will be the maximum profit that we can get? All right, there's some sort of DP. Yeah, so you kind of can think of this way. So you're gonna have to take some, you will have to take some job, right? No matter what. So let's say we sort by start time. Okay, we sort by start time, and we can say if we include a certain job, if I take a job, right, like say DP index, right, if I take this job, what will be the best I can get? Okay, that sounds all right. If I take a job, what will be the best that I can get? So DPI, and I say, okay, if I take, like, let's say if I take the first job, right, and then because its end time is 3, so the next job I can take can only be 3 or further, right? I cannot take any other jobs because of this restriction. And because I sort the start time, so whenever we have an end time, we can binary search. So okay, that'll be fine. So we'll have 3, but we will also have bunch of stuff, right? Then what do we say? We go through them one by one. That doesn't seem to be right. And then the length is 5 times 10 to the 4th, so I doubt we can do that. So what do? We have 2 start at 3, right? We have 2 start at 3. So we can say binary search. So we find something. So we say, okay, well, take that, right? Basically, we say take that. Or we can skip this and we can take the next one. And we just keep going, try everything. I mean, you should, right? Try everything. So will be the max if I take this job. But then, yeah, you have to go to the next one, right? Because the start can do anything. You take a job, and then your binary search, like in this case, if I take the first job, it ends at 3, right? So I have 3 jobs that I can do. Or, hold a second. What if we change the DP? So DPI is the maximum profit I can take from job I, all the way to the end. How about that? Yeah. From job I to the end. So it doesn't have to take the job, right? It doesn't have to take, which means when we take this, right, the job, and then the end is 3, that we binary search, so it's just gonna be find the maximum from this towards the end. So it'll be take this and plus dp01, dp2, done, right? The max from this towards the end. So the max from this towards the end, so you will, because it's from this towards, so you can either take this one or you can take this one, right? You can take the 2, starting from 2, and this one will give you 5. So you will say starting from 6, going toward the end, right? So that's a DP. So that still feels like, because you have to go through every single thing, right? From DPI, you have to go through every single thing because you want to know, starting from this, what is the maximum you can get from this position towards the end. Yeah, you will do DP2, we call DP0. DP0, you have to go take 0 or take 2 or take 1, right? Or you don't take, yeah, you don't take, so maybe, hold a second, maybe let's, right? So maybe we can say, if we say, so after we sort, right? After we sort everything, so we can say DP index is equal to the max profit, okay, in array from index towards the end, okay? So if we want to do DP index, we have 2 choices. Either we, so choice 1 is we take a job index, right? Then we'll do, we'll do a binary search. We'll do a binary search to find the smallest index that is larger, or larger than the current. And we run DP that index, I call it J. Smallest J, right? We'll do that. Or do not take, right? We do not take job index. And in that case, we just run DP, index plus 1, right? This towards the end. Okay, let's see if this, oh, what are you doing? If this one is correct. So let's go back here. So we'll do this. 5. That is not correct. Because today should be 6. Right? Today should be 6. Yes. But that's also not right. We shall copy first. Come on. Today is a hard problem, so we're okay. Let's just do Python. That'll be fun. Is it doesn't open the Oh, that's Java. Oh, it'll take some time. Wow. That take way too long. Man, you sure? What the hell? It's like taking forever. Dude. I thought one of the benefits of doing this is it's gonna be fast. Disappointing. Alright, anyway. So okay, let's give this a shot. We know some things we need. Func tools. Func tools. Alright, we know this one is needed. Okay, so we have to sort this thing first based on the start time. And if the start time is the same, how are you going to sort the end time? If the start time is the same, I don't think it matters, the end time. We only care about the start time, so the end time doesn't really matter. So we're going to say combined time, okay? Sorted SEP, okay? For SEP in zip start and time profit. Okay. So we'll sort these into combined and it'll be fine. And then what we need to do is we need to def a dp, okay? So index, right? dp index, that is gonna turn int, and we just say add value cache max. Oh, Control J, yes, none. Okay. So now what do? We have the dp, we have the index, and then if index is like, if let's say index is equal to len, I might as well just do this, n equal to len start time. Yeah, we do this and then we call it n. Oh, that's not right. N, right? If index is equal to n, that means we go to the end. That is when we shall return 0, right? Or return 0. Otherwise, we say option 1, right? Option 1 take not take the current job. So if that's the case, we can say res equal to dp index plus 1. Done. That's it. If I don't take the current job, it will be the next job to the end. Option 2 will be option 2 take the current job and find the earliest next job to take to run DP. Oh, I need a ruler. I'm pretty sure they should have something for ruler. Okay, so to run DP, so basically, I need to say from bisect import, what is this gonna be? Bisect left, right. Okay. So if it's right, then if it's the same, we go for the next one. Nah, I feel like no. Let's go. I think it's bisect left. Okay. So if it's bisect left, we can say j equal to bisect left. All right, bisect left, combine time, and comb time index 0 0. No, and so 1. Right? This is the and. And we search for it. And then we have to have a key equal to lambda tuple, and we'll compare tuple 0. I think that's the syntax, right? Actually, I'm not sure. I need to check. Wait, I always type it wrong. VT Python. All right. From bisect import form. Okay, so a equal to, let's say 1 3 50, right? 2 4 10 3 5 40 3 6 70. Okay, so it's a bisect left a, you know, we're looking for the second one, so a1 1, so it's 4, right? Then we need to bisect 4. Oh, bisect 4 is too easy. Let's go 0 1, so bisect 3, and key equal to, you know, lambda tuple. So basically it's tuples on A. What we're gonna do, we're gonna compare on 1. No, on 0. 2 0 1 2. Yeah, I think that's correct. Right, so now we get a J, and we basically say return maximum, because I will take the current, so combine time index 2, right? Hold on, I have a res, and this plus dp j. right? Because it's my end time, right? The end time. It's either slightly larger than me or it's the same. What if it's the same? You start and you end at the same time. Is that possible? Will we have this? No, you will not. It will always be different. So we can just do J. Right? Great. Then we'll just return dp0 because we want to find the maximum, so we do dp0. All right. We're gonna do. Let's see. Well, first one is 1, 2, 3. Right. 1, 2, 3, 3. 3, 4, 5, 6, 50, 10, 40, 70. And the answer is 120. Okay. The second, I probably can copy and paste this. Answer is 150. So okay, this shall be start time and time profit. This is our job scheduling. Okay, let's try this. So we'll get out of this, and then we'll run. This is 2024. This 2024. This. All right, these two pass. I don't know. Maybe that is it. Now it's yank. Alright, we run here. Oh, they actually have 3 examples. I only run 1. Alright, I think it's pretty straightforward. Yeah, it's pretty straightforward. Did they change? Something's changed. Something has changed. This is 1, 2, 2, 3, 5. Not too bad, not too difficult. A DP problem where DP index is the total, is the max profit starting from job index. Here, job array or comp time array in the implementation is a sorted array. Sort is a sorted array by start time. Right, sorted by start time. And to solve DP index, we have 2 options. Either not take job index, and in which case the result would be DP index plus 1, or take job index, in which case the result would be the profit of job index plus dpj where job J is the earliest job whose starting time does not overlap that of job index. Yep, that'll be it. So runtime, well, we can call it O2n, because we do this, right? We hit every single n, and here we do it, basically we call it 2 times, right? O2n, O(n) log n, because we have this. Okay, so I think all I need to do is check my solution previously. Yeah, 2 solution previously, and I check this one. So 31 test cases, 30 test cases. It's even more. This is the bottom up. I bet this is a top down. That looks complicated. Yeah, it looks complicated. Yep. Go right to left, so you can do that. Yeah, that's fine. Key, we do this. Max of this plus this. Yes, exactly. It's exactly the same as this, but this is a bottom up. Oh, you are kidding me. I don't have to do this way. Holy crap. Better way. Oh, it's a GCC, man. Comp time. Sorted. Zip. Start time, end time, and a profit. A profit. Yep. Gorgeous. Alright, this is an easy one. I shouldn't say easy one, this is a pretty standard one. So yeah, this is not that hard to solve compared to the one we had yesterday, which I know always had a lot of trouble dealing with. There's a difference between all these things. Alright, now we're back. So we are going just to end this. Sum of squares. Sum of squares of special elements. You are given a one-indexed integer array, nums of length n. An element nums I of nums is called special. If I divides n, which is this, return the sum of the squares of all special elements. So a special element nums I, it happens if n divides I, so n divides the index. Okay, so n divides the index, we get a value out, and it will sum its. Okay, so we'll go back here. So we'll go up. Oh, what are you doing? Control. 3J. So da. Oh, what the hell? Alright, so this will be for int 0, 4, int I length I plus if nums.length mod I is equal to 0, rest plus equal to nums I don't know, I go times nums I. That's about right? What else can you do? What about 0? A 1 indexed. Jesus. Oh no. Oh yes, it's fine. 1 index is still I. Nah. You can do NeoVim, but I think Vim will be faster. Alright, NeoVim will be slower. Maybe we can do NeoVim on this. 2778.java. Oh, it's okay. It's only when you open something that's already... Oh, because it's not, there's no LSP associated with it, that's why. When you have LSP associated with it, I guess that's why it's slow. Maximum beauty of an array after applying operations. You're given a 0 indexed array and a non-negative integer. In one operation, choose an I that hasn't been chosen before from range 0 to the end. Replace nums I with any integer from the range nums I minus. Okay. The beauty of the array is the length of the longest subsequence consisting of equal elements. The beauty of the array is the length of the longest so it's a subsequence, which means the beauty of the array is the count, right? The max count, the max frequency of an element. Return the maximum possible beauty of the array after applying the operation any number of times. So we can do any number of times, but choose an I that has not been chosen before. So if I've chosen it before, I cannot choose it again. You can apply the operation to each index only once. Okay, and the first one is 3, k is 2, right? K is 2, so I can move everybody towards 3. Except from the second one. Everybody else can move to 3. Or to 4. Yeah. The second one is, yeah, it's already, okay. So basically, each one, you can sort, or, how would you... So you're basically gonna go through every single value. Yeah, basically just go through every single value and then see what is the overlap, right? So the first one, it can go from 2 to 6. And next one is 4 to 8. So kind of find the overlap. No, so each value have a range, right? And then you can rearrange those things. Then the question is asking, what is the max possible overlap, right? Among all the ranges. Isn't that a question? The max number of overlaps. So I can create the overlaps. Okay, I can create the overlaps. And then I can sort. Oh, same problem. How do you sort? You can sort the overlaps. Okay. And after you sort it, you go from the front and you can count. Each time we hit the front, we count. Each time we hit an end, we will decrease a count, right? And then you just find the maximum count you can get. So basically in this, what we're saying is something like this. I mean, maybe there's a better solution, right? So in this case, we have, first one, we have 2 to 6, 4 to 8, -1 to 3, and 0 to 2. So if we sort it, it'll be -1, S, 0, S, we have a 2S, and I have a 2 and, right? And we have a 3 and, 4 and, 5, 6 and 8 and, right? So every time we hit this, we're gonna go, okay, so this is a 1, 2, 3, boom, so now we have 3, so now we have 2, because we hit an end, and then 1, 0. How does it become negative? Oh, 4 is start. Yeah, okay, 1, 2, 3, right? And then we have 2 minus 2. So that's 1, 2, and becomes 0. Okay, so we can. How do we do this in Java, right? Basically, we want to sort based on a pair's first value. It's a good question. I actually don't know. I actually don't know how do we do this in Java. Because I don't have pair, but I think this one has pair, right? Do you have pair? We say integer and integer, right? P equals new pair. I don't know. Does this one work? I actually don't know. Pair. Oh, I can just do does not pair. Java sort array of array. And start has to go before, right? Array of array. Is that possible? Sort to the array. It's just I always have the issue with this. Oh, comparator. Oh, maybe this. We can do this. Yeah, you should do compare bot. Okay, so we can try. Let's try. Yeah, I am going to use this method. This counting method. I hope there's a better one, but for now, that's what I think. Okay. So what we need is int, just this. We call it ranges. Not ranges, this is and extremes. Okay, extremes. New int, that's gonna be nums dot length. That's gonna be 2. Okay. For int n, no, we need I smaller nums dot length. Unfortunately, I plus plus. Okay. Then we do extremes I 0. Oh, this has to be double the length, and this has to be plus equal to 2. All right. So I extreme. I forgot here. Should be equal to 0. All right. What happened? What happened? Oh, it's not nums dot length times 2 as well. Wait, what happened here? I was already defining this. I was already defining the scope. Where? I have I. Is it this? Cannot resolve I. Huh? What? Isn't this how you write loops? Oh, K is. How about JK? JK is fine. Where is I? I don't remember define I anywhere. I don't know. I don't know what happened. Oh, shoot. Sorry. Okay, so this shall be nums I minus k. So this is a start. And extremes I plus 1, 0 shall equal to nums I plus k. And this is end. And extremes I plus 1, 1 shall equal to 1. Okay, indicating the end. And this is still 0, so it's fine. I plus equal to 2, move to the next one, blah, 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 blah. So we handle all this. Once we're done, arrays dot sort. Okay, extremes. And we need comparators, which we'll call a tuple 1, tuple 2. Okay, and we say if tuple 1, tuple 2, if tuple 1, 0 is equal to tuple 2, 0. Okay, then we say integer dot compare tuple 1, 1 and tuple. You know what? I think it's probably sorted this way already. So yeah, I'm not gonna just waste. I feel like it probably sorted this way already. So we just sort it. Okay. So after we sort it, we're just gonna go from start. You know what? You know what? I think we can be even smarter. -1. Okay? Just indicating start. Otherwise it's this. It's fine. Right? And then we say interest equal to 0. And we're gonna go just one by one. For int tuple of extremes. Okay. And we need a current. Int current 0. So we say current minus equal to tup 1. Right? And then res equal to math.maximum res and current. Once we're done, we will return res. Okay. Let's see. Do this. Let's see if it's right. It's correct. Out of bound. Oh, but of course, because the I, okay, that is a problem. That is a problem. So I think easier way will be to not do it. So we're gonna do this. We don't do it here. This is still gonna be plus plus. Okay. Right. But when we do extreme, this is gonna be 2 times I. Right. So this is also 2 times I, and this is gonna be 2 times I plus 1. Okay. This is gonna be 2 times I plus 1. So yeah, if it's a 0 and a 1 and a 1 will be 2, 3, and then 2 will be 4, 5. Yeah, I think this should be right. So let's try this again. I guess I cannot. So you have to use the AB. Yep, I have to use AB. Okay, that's fine. So I need to, can we like do it in 2? Say extremes and top 1, top 2. I thought I can avoid it. And we say top 1 0 if it's equal to top 2 0. Then we'll do integer dot compare top 1 1, top 2 1. Okay. Oh, I think I got. Okay, this is this. Right, and then otherwise just integer dot compare top 1 0 and top 2 0. Okay. What do you think about this? Is this good? Yep. I think it makes sense. And will be O and login. Let's see if it works. It does, but it's super slow. Okay. 300 milliseconds. That is slow. As slow as it can be. So definitely not the right answer. Yeah, this is not the right answer. So 2779. We produce all the ranges and sort them. Each time, no, the problem is equivalent to asking what is the max number of overlaps among the ranges. Thus, reproduce all the ranges and sort them. And then, right, and then we go through each extremes. If we hit a start, we increment the count. Otherwise, we decrement. We return the max. Yeah, max such count. Owen login. Based on the performance, this is apparently not the best solution. There must be an ON solution somewhere. Or yeah, I shouldn't say that. I don't know. There may be still ON login, but it's simpler than this. That's fine. Yeah, it's fine. I mean, it's just require us to think a little bit more. Okay, so how can you do it faster? Or maybe just sort it once. You don't create a new array. Yeah, the creating of the new array is definitely causing a lot of time. So what if we sort the original numbers? Okay, we sort it. That probably can make it better. So if we sort it, then we get 1, 2, 4, 6, right? I mean, we can just merge towards the center. I'm not sure we'll merge towards the center. So we sort it, okay? Then what? Then for each one, because one cannot go down, right? It's not good. So one must just plus. So with the first one, we can plus k, right? And then we have kind of a higher bound. And then we see how many values can we cover. So the smallest, if we go the maximum. Yeah, so with each one, if we go maximum, right? Each value, if we go maximum, so this one will be 3, right? That'll be 3. Then what we want to see is what will be the value. So we'll have something until minus, right, to also be 3 or smaller, so that everything in between can be included, which means we'll go everything with plus 2 and then plus 2 again, so it'll be 5. Then we'll binary search for 5. And then, so if we include this, yeah, it could be because it's always going to be consecutive, right? Because if it's not consecutive, you can always include a 1 in between. So now 5 is this, so we have 3 in between. So 2 plus basically 2k will be 6. So that's also 3. And if we find it, because I'm going to use binary search for this, is that erase the binary search, right? So if we find it, then we need to plus 1. If we don't find it, because that's going to be an insertion point, it's always going to be plus 1. Yes. So what we're going to do is yeah, it's going to be the insertion point. What we're going to do what we are going to do. It's the insertion point. Okay, we can do that. So it's kind of solution number 2. Let's go to 21K. I think once we done with this, we can call it a day. So this one use binary search. For each, so the first observation, we sort K, right? We sort nums first. Then a key observation is that the longest subsequence of equal elements must come from a subarray of the sorted nums. This is because if we skip some number, then the skipped number can always be part of the beautiful number, right? Beautiful numbers. Then we check, right, each number in the sorted array and find and use binary search to find the position of n plus 2k, right? Any value in the sorted array that is smaller than n plus 2k can be included in the beautiful array because such a number is, yeah, it's just, it can be included. We know why I don't want to just keep writing out, because you n plus k will be the smallest, increase, and then something bigger minus k. So if these two can overlap, right? If these two are the big minus k is smaller than the smaller plus k, or smaller equal to, then they can overlap. So here is the solution. So first of all, arrays.sort. I think this will be fine. Okay. And then interest is equal to 0 for int I 0 I smaller than nums.length I plus plus. Okay, what we're gonna do is int j is gonna be arrays.binary search nums with nums I plus 2 times k. Okay, and we say j will equal to j plus 1. Okay, j is larger than 0, larger equal to 0 than j plus 1. Otherwise will be minus j plus 1. Right, minus j plus 1, because we do minus insertion plus position minus 1, so we plus 1 minus, that will be the j. And we'll say res will equal to mass dot maximum res and j minus I. That's the total number of things in between, the things in between. Why you highlight this? Because this should be a comma. And we'll return res Okay. What the hell did you do? I think I typed P. I'm not supposed to do so. Alright, so run this. If it's correct, then we are going for it. Yes. This should be faster. Ooh. We got it wrong. Holy crap. Output 1 is supposed to be... Ugh. Oh. Oh. Yep. There's no, there's no bisect right for this. Damn. How do we do bisect right? Can we do, not sure, instead of nums I, can I do, I don't know, nums I plus this plus 0.1. I don't know. I don't know how the binary search works. Can I do that? 0.1? No, it has to be. Ugh. Ugh. Is a bisect right? Do they have a bisect right? There's no guarantee which one will be found. Jesus. Are you kidding me? Are you absolutely kidding me? Yeah, we have to write bisect right ourselves. Jesus. Alright, I definitely don't like it. But Java is Java. There's no... Okay, let's do this. Private int bisect right. Array and int x. Okay. Okay, so narrate bisect right. Int low and high. Low shall be 0. Right, our length. Okay. While is your low smaller than high, int mid is low plus high divided by 2, which is also biased towards the left. I say if array mid is larger, right? If it's smaller equal to x, then low will equal to mid plus 1, else high will equal to mid. Right, because we're biased towards the left, so we do mid plus 1. And we'll also do array smaller equal to x, which means if it's equal to, I'll keep pushing to the right. right? And eventually when it comes out is because low equals mid plus 1. Then we come out. So I think I can return low. Okay, so with this in mind, instead of doing this, I will be just, I don't even need to call all these, right? I can just say this, bisect right nums and nums I. All right, let's, this actually makes things a lot more interesting because I can, oh, I didn't put it here. Is that right? Come on, bisect right. Ugh. Ugh. So I think that's the bisect issue, right? Something with a bisect. I should be right. Come on, this is just writing a bisect. Oh, I know. I forgot to add. My bad. Yeah, it's like this bisect is right. Come on. There we go. Still. That was ugly. Okay, this is another solution we can live by. Let's go down to the end. There's another solution. I mean, what I'm thinking is maybe I can just do +1. We can just do +1. We search for +1. Okay, I can binary search for +1, whatever value +1. And if it's the same, then whatever we found will be the right one. If it's going to be, if it's a match, then we just use that. If it's not a match, yeah, I can actually, I think I can I can change this. Hold on. Know that we need to use a trick to obtain bisect right with Java's binary search. All right, so basically this we're gonna do +1. All right, and then yeah, we can say if j is smaller than 0, minus j + 1. Something like this. Now this will allow me to do bisect right. There we go. That. Let's see if this one will be faster. No. No. How? +1 is not enough? Dude. Oh. Man. I you know, I don't know why. No idea. No idea. +1 doesn't work. Why would +1 does not work? Alright, I need to check. That's strange. Alright, how about we remove some values? I don't know, maybe we do this. Does it still work? Now it's just curiosity. Okay? Right now it's just, curiosity. Because I want to know. I want to know why this bisect trick doesn't work. Okay? Because it feels very intuitive for me. And like, why would it not work? You're kidding me. Okay? You're kidding me. Is it all correct? Where does it go wrong? So I'll put 22, but actually 21. Okay, so no, it's way too many. Oh. Okay, so what I'm gonna do is I'll copy the see, all I want is just to know why. Oh no, yank it. That's all I'm asking for. Right? I'm not asking for a lot. Right? So basically I'll do that. And I'll say int jj, okay? Let's call it bisect right. Nums and nums I plus 2 times k. Right? And then we say if jj is not equal to j, then we can do we'll print something out. Print sys dot out dot print line j. Okay, and same thing, jj, and sys.out.print line nums.toString. I don't know, is this gonna work? I know we'll, that's fine, you can return. System. Ugh. Seriously. How do I do that? JavaScript nums array to string. What is the string.join? Oh my god. Java is so bad. How can anyone use Java? This is ridiculous. Dude, this is ridiculous. Oh my word. Can I use this? No, you can't. Okay, what? Wait, hold a second. Maybe I don't need to string. Maybe I can just go print. My god. Whatever it is, this is just ugly. Alright, can I not to print line? Oh. Print without new line. Printf. Printf. Okay, so we can printf. That's printf. So printf. Actually, we shall go for int k equal to I. K smaller. I can nums not lines. That's fine. K plus plus. All right. What I want is system.out.printf nums I. Can I plus this? Convert integer to string. How do I do that? String.value of. Or no, string. I'll go string.value of. So string.value of the amount of verbosity. Come on. Oh, k is already defined. You gotta be kidding me. My god. And this is p. Oh, you're telling me we have multiple issues. $19.18. Wait a second. Wait a second. Why is output looking like this? I'm on new, so I can say new file? No. Hold on. New? So anyway, we have 19. Yeah, that's actually not the best way to do this, right? But anyway, so we have 19 and 18, and we're starting from, so J. So my j is 19, but the actual j is 18, and the current I is nums p, yeah, is 18. So plus 2 times 8, 18 plus 16 will be 34. Right. So the j should be, oh, we should print out. We should print out I as well. Yep. Let's do a system.out.println I. And I gotta understand, why there's only 2? Or are you just loop around? Anyway, 9, right? And it's 18. 18 plus 16 is 34. Right, so 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, plus 1. Oh my god. Oh my word. And this doesn't, this doesn't work. Because you don't know which one it returns. And in this case, it just returns, right? 10, 11, 12, 13, 14, 15, 16, 17, 18. We should return this one. But in my case, I have plus 1, which is 35. And then we just go whichever. Yeah, that's not going to work. That is not going to work. I think the only way, okay, can we convert an integer? Okay, so we can say cast integer array to, let's say, a float. Can we do that? Oh, yeah, it's the same thing. Okay. Yeah, casting won't work. Okay, so I'm gonna cast it. Okay. I still want this one to work, so I'm gonna cast it. So we sort it and we say float fnums nums.length, all because I want this trick. Right, for int I 0 I smaller than nums.length, I plus plus, and we say fnums I or equal to float nums I. That's it. And then we do blah. F arrays.binary search f plus 0.1. If this, we don't do any of this. All right, does this work? No. Binary search doesn't have. Oh, that's a double. All right, let's just double it then. Double, and double. How about this one? You have this? Yes. Yes. This one is correct. Holy mojo. I need to convert the nums to a double nums. All right, come on. Show me some love. Slightly faster. faster than, you know, writing your own. All right, so here is, we need to go Control W and quit. Yes. Then go G. All right. Good question. Oh, and log in. There seems to be a faster solution. Sliding window. Holy crap. Okay, I think this one deserves a little bit more attention. So I'll, you know what? Yeah, let's end it today because it's kind of take a long time. But we're gonna go back to this again tomorrow. I find this interesting because it's not really that hard. I was able to solve it in 2 different methods, but the runtime still suggests there's something better out there. So we'll deal with it.